Alright, so in this video we're going to take a look at nonlinear simultaneous equations as an exceeding standard opportunity on the standard that we've been covering on simultaneous equations. So when we are going to solve nonlinear simultaneous equations, we're going to take a look at when we have a parabola, so this little u guy, so these are parabolas, and their solutions with straight lines. So there are three different possible solutions when we have a quadratic equation or parabola with our linear equations. We can have two different solutions. We can have one solution where it looks like it's touching more, but if we really zoomed in, like if it was on Desmos, they would be only touching at one point. And then we could have a parabola and a straight line that never intersect. However, before we get started on this topic, we need to briefly look at how we can factor quadratics. So we know, for example, if we had an expression such as, let's say, 4x squared minus 6, we know that we could factor out a 2, because 4 and 6 have a greatest common factor of 2, and then I would have 2x squared minus 3. And that would be factored out. But when we have something that looks like this, we can also factor this out. So we're going to take a look at how that works. So let's do this in red. So, and I'll just erase this. We don't need this anymore. So when we do that, I like to do this M and A trick. So M and A. So in front of our x, we have a coefficient of 1. So what we're going to do is for our M, we're going to put the value of our coefficient of 1 times 4. So those two, and that's going to be a 4. And then for my A, I'm going to put the coefficient of my second term that has just the single x, which is 5. And then why I have M and A is because M is going to stand for my multiplication, and A is going to stand for addition. So the idea is we want to think of two numbers, so two numbers that will multiply 2, 4, and the same two numbers that could add to 5. So in this case, if we think of those two numbers, we have 4 times 1 and 4 plus 1. So 4 times 1 makes 4, and 4 plus 1 makes 5. So these are going to be what's used in my brackets here. So I'm going to have x plus 4, and I have x plus 1. And why this works? Well, we know how to expand this out to double check. So we could expand this out to double check, and I'm going to use the area model to show us how we could do that. So let's do the area model. We have an x, and we have a plus 4, and we have an x, and we have a plus 1. We do our area model. X times x is x squared. X times 4 is 4x. X times 1 is just an x. 1 times 4 is a 4. And then if we add up our area, we're going to get x squared plus 5x plus 4, which brings us back to our original expression that we had. All right, so now let's take a look at another example here. Again, I'm going to do my M and my A. Underneath my M is going to be, I have a coefficient of 1, and I have this negative 12. So negative 12 times my positive 1 is going to give me negative 12. And then for my A, it's going to be the coefficient of my term with the variable x. So I've got a negative x, so negative 1. So this is going to be in here. So I need to think of multiplication of two numbers. It's going to give me negative 12. And I need to think the addition of two numbers. It's going to give me negative 1. So a good trick is to think of, for the multiplication part first, what are the factors of 12? We have 3 and 4, and a 3 and 4 could definitely make 1. So I know now my numbers, it's going to be 3 and 4, but now I just need to think of my signs, because I have negative 12, and then I have negative 1. So if I have negative 4 plus 3, it's going to give me negative 1. So that means I need a negative 4 here. So 3 times negative 4 also gives me 12. So I'm going to have x minus 4, and I'm going to have x plus 3. And again, we can double check using our area model. So here we go. And I've got x minus 4, and I've got x plus 3. X times x is x squared. X times 3 is 3x. X times negative 4 is negative 4x. And negative 4 times 3 is negative 12. Add up my area. X squared. 3x minus 4x is negative x. Subtract 12, or negative 12. And then we can double check our work. So here are 6 for you to try out to see if you can factor these out, because this is a prior knowledge skill that we're going to need before we can continue solving simultaneous equations where we have one of them that is not a straight line. All right, so going back to possible solutions, we can have either 2, 1, or none of our solutions when we have a quadratic with a straight line. So if we take a look at our first example, we have this quadratic, which is in the orange. Y is equal to x squared minus x, subtract 18. And we have the straight line equation, y is equal to x, subtract 3. So here in Desmos, we can see the two solutions, this one here and this one here. So one of the solutions is negative 3 and negative 6, and the other solution is at 5 and 2. So this one has two solutions. Now, of course, we can see that, and we've solved a simultaneous equation by graphing, but what we're going to do is we're going to see if we can do this using algebra. All right, so let's see if we can solve this using algebra. So we have our two equations that we're going to solve at the same time. We can do the exact same thing we've been doing, is label them 1 and 2. And we can still use those strategies that we've learned, like elimination and substitution. Now, from this example, hopefully you guys are clicking that there's something similar to this, to substitution. Notice that both of our equations are equal to y. So since they're both equal to y, we can say that they're equal to each other. Equation 1 is equal to equation 2. So let's set them equal to each other. X squared subtract x minus 18 is equal to x subtract 3. Now, what we are going to want to do is we're going to want to set, we're going to want to rearrange so that one side of our equation is going to be equal to 0. So to do that, we can, since more of the terms are on this side and we already have a positive x squared, I'm going to try to get these terms to the other side. So for that, we're going to have to subtract x to both sides. This is going to cancel. We've got now x squared, negative x, subtract x is going to be negative 2x. Subtract 18 is equal to negative 3. And then I'm going to have to add 3 to both sides. This is going to cancel, and I'm going to get x squared minus 2x, and that's going to be subtract 15 is equal to 0. Now that it's equal to 0, I can use that M&A strategy to help me factor this quadratic equation. So M and A. For my A, it's going to be the coefficient of the term with the x variable, so it's negative 2. And for my M, it's going to be, remember we have a 1 here, so it's going to be this 1 times this negative 15, which is going to give me negative 15. So now what we're going to want to do is we're going to want to think of two numbers that multiply to negative 15 and two numbers that will add to negative 2. So if I think of factors of 15, 15 and 1, and 3 and 5. So 3 and 5 is probably my best bet, 3 and 5. And if we think about 3 and 5, the difference between those numbers is 2, so I'm probably on the right track. And now I have to think about my signs. So if I have 3 plus negative 5, I will get negative 2, so that means this will also be a negative 5 here. So now, if I factor this out, I get x subtract 5, and then the other parentheses is going to be x plus 3 is equal to 0. So now I have a number times another number is equal to 0. If we want anything multiplied to make 0, that means one of these in the parentheses needs to be equal to 0. So we can say that x subtract 5 is equal to 0, or we have x plus 3 is equal to 0. And then we can solve for x. So in this case, x is equal to 5, or x is equal to negative 3. And if it was x is equal to 5, 5 minus 5 makes 0, and negative 3 plus 3 makes 0. So now we have x values. Now we need to figure out the y values. So it would be easier if we substitute this into equation 1 or equation 2. Hopefully you're seeing that it's going to be easier if we sub this into equation 2, because it's the one without the x squared. So we're going to sub into equation 2. But we're going to have to do this twice because we have two different values of x. So we've got y is equal to x minus 3, and then we have the other one, which is y is equal to x minus 3, but we're going to change the values of x. So y is equal to, instead of x, for this one we have 5 minus 3, and then for the other one it's going to be y is equal to, instead of x, we're going to have negative 3 and subtract 3 and solve for y. So y is equal to, this one is 5 minus 3 is 2, and this one here is negative 3 subtract 3 is going to be negative 6. So when I have my two equations, or sorry, my two solutions, one of the points is, I used 5, so 5 and 2, and the other solution is negative 3 and negative 6. And then if we squeeze in a little screenshot from Desmos, we can see that we are correct here. So negative 3 and negative 6 was a point where the quadratic equation, or the parabola, intersected with our straight line, and we have 5 and 2, which is the other point that our straight line intersected with our parabola. So here are 4 questions to try that out using the algebraic way of figuring out where our parabola and our straight line are going to intersect. And of course, you can use Desmos to help you out and double check to see if you got it right. So good luck!